Hello, everyone. Happy Tuesday. Thanks so much for joining us today for Quality Count's webinar on drones and data collection. My name is Roxy Booth. I work on QC's marketing team, and I will be your host today. On the right-hand side, you will see a chat box. If for some reason you don't see it, if you look on the bottom of your screen, there's a little icon with 3 dots, or a little chat icon you can click on. And then that will bring up the chat box. Feel free to use this as a parking lot to ask any questions throughout the presentation. You can direct them specifically to me or have all attendees question. We'll address all of the questions at the end of the presentation during our Q&A time. Today, we're excited to have Tim Miller share with us about drones and their usage in data collection. Tim has over 100 hours of flight time, and he holds his UAV license. Thanks, Tim, so much for taking the time to share with us about drones.
Thank you, Roxy. I'm glad to be here. Hello, everyone. My name is Tim Miller, and I will be taking you through a brief presentation on drones and data collection. So we'll go ahead and start. A few of the points that we will touch on today. What is a drone? Some statistics and trends, regulations, deployment process, project examples, advantages, applications, and we'll have time at the end for some questions. So to start, what is a drone? A drone is classified as a UAV or unmanned aerial vehicle. There are 4 main types of drones: fixed wing, the single rotor, multi-rotor, and the hybrid, which is a combination of both. There are 3 main components to a drone: the aircraft itself, which is the props, wings, engine, and guidance systems; the gimbal, which stabilizes the payload and fixes it to the aircraft; and the payload, in this case, a camera. There's a lot of other stuff that goes along with this: digital storage, monitors, RC controllers, different types of payload you can put on the drone, sensors, LiDAR, thermographic cameras, different types of lenses depending on the environment you're going to be doing data collection in, and of course the software for both flight planning and data processing. We'll talk a little bit about the statistics and trends. This is according to the FAA as of July 21st, 2020. There are over 1.6 million drones registered. 1.1 million of those are recreational drones. Over 400,000 are commercial drones. And there are 184,000 remote pilots certified. There are predicted trends from 2019 to 2024 for recreational drones, 1.35 million to 1.59. And for commercial drones, 385,000 to 1.9. As you can see, there's going to be a lot more growth in the commercial drone department, and it really has been kind of exploding. The main industry sectors that can see the most drone growth are going to be energy, transportation and warehousing, agriculture, construction and mining, insurance, and media telecommunications. These are the main distributors and manufacturers of drones in the world, with DJI holding over 70% of the market. I show you all of this to highlight the fact that the commercial drone market has exploded and will likely continue its upward trend in the foreseeable future. With so many options available, we know it can be difficult to sift through the static in order to find individuals or groups with the proper knowledge and the experience necessary to successfully execute flight missions. QC has spent a great deal of time and effort researching, field testing, and implementing drone tech into our regular operations. I can say with confidence, since I'm one of the ones that have been testing it, that we both understand how to properly use this technology and have the experience required to facilitate your data collection needs. Talk a bit about the regulations. The Part 107 is the Federal Aviation Administration's rules for governing small unmanned aircraft operations other than model aircraft. Basically, it covers a broad spectrum of commercial and government uses for drones weighing less than 55 pounds. Some of the main restrictions include no flying over 400 feet. You can fly it during civil twilight with the use of anti-collision lights. No flying at night. No flying over people. No flying over moving vehicles or from moving vehicles, or in restricted and controlled airspace. These regulations are being adjusted and changed sometimes almost monthly, so it's very important to pay attention and to know what's going on. All right, our deployment process. Once we have a location and collection times, we need to make sure that we are cleared to fly over the location in question. If we find out that we're not, we can use LANS, which is the low altitude authorization and notification capability. Essentially, it's part of the FAA that allows you to request permission to fly in controlled or restricted airspace, as well as request operational waivers, which allow you to perform such actions as flying at night or over crowds of people. Permission can often be instantly granted by LANS via mobile applications such as Kitty Hawk. However, operational waivers need to be submitted 90 days before executing a mission. We also know how confusing and a bit overwhelming all this can be. We have thorough understanding and extensive experience in dealing with these regulations and restrictions. We handle all of the planning and coordinating, so you don't have to worry about it. Once we're ready to go, we need to select the aircraft. Of course, it's going to be based on the mission parameters and payload requirements. Once we've selected an aircraft, we're going to go with the payload. In this case, we'll select the camera. Once you've done that, then you've got accessories, specifically different types of lenses and filters depending on the environment you're collecting in. And you might want to have a visual observer along with you, depending on how much traffic will be active in the area you plan on flying. It's just important in case you have a lot of birds or other airplanes or just even cars and people walking around. Sometimes it's good to have somebody else keep an eye on that so you can keep your eye on the drone at all times. All right, next part of the deployment process will be flight planning. Usually you want to visit the site the day before you fly to scout for any issues, make sure you understand the lay of the land, buildings. Then you would use your flight planning software. Pix4D, Drone Deploy, Precision Hawk are just a few of the main ones. These allow you to define your flight parameters, pretty much everything from altitude, speed, gimbal angle, as well as it allows you to actually plan your flight. You can do this off-site or on-site, so it's pretty intuitive. You always want to monitor the weather up to and including the hours marked for collection. Conditions may require a brief suspension or postponement of the mission. Specific lenses and filters may be applied, however, to reduce glare and reflections that can prevent overexposure on bright days. These are all things you want to pay attention to so you know what you're going to deal with when you get out there. Pre-flight systems check, sensor adjustments, GPS and IMU calibrations, a short test flight to ensure proper center of gravity and stability. And finally, environment awareness, knowing where the people, the wildlife, the buildings, and other aircraft are at all times. Once you're ready to go, you can fly the mission. After it's complete, you can load the data up to the software for processing. In this case, it's an orthomosaic map of a parking lot in a building used for parking studies. Orthomosaic is an aerial photograph that's been geometrically corrected so that the scale is uniform with the same lack of distortion as a map. I mean, these are pretty incredible. You can achieve up to centimeter level accuracy depending on the type of equipment you're using. You can also take that information and feed it back into the software and you can come up with a 3D model. These, as you can see, are just really cool. They allow for detailed inspections, damage assessment, energy loss monitoring, and precise calculations on material amounts. And they're just really cool. There's a lot you can do with this. You might need a tethered drone if you have a mission that requires you to be up in the air for more than 30 minutes. Tethered drone maintains connection with the ground unit, which supplies the drone with energy and can receive data from the drone. It's really cool. You can pretty much keep it in the air indefinitely. As long as you're feeding energy into this thing, it'll stay up there. So it allows for persistent video collection and automated software for tracking and counting. All right, next we're going to talk about some project examples, some things that we've done, some things we can do. Roundabouts are a perfect candidate for this type of data collection. The elevated position allows for unobstructed viewing, no large vehicles, no signage, no glare. You can pretty much put the thing in the air and go. And it really allows for some unique angles as well. With the 4K footage, the clarity is unparalleled and it allows the processing time to just go much, much quicker. School operations studies are another big one, monitoring both vehicle and pedestrian traffic, queue studies, locating problem areas and points of potential conflict. Typically, with traditional methods, you would have to have several locations with cameras on the ground to be able to collect all this data. With one drone in the air, you can pretty much get a clear picture of everything that's going on as it's happening. You can see the queuing here, you can see the queue points where they're turning here. So it just allows you to have a full and comprehensive view without having to put together multiple pieces of data from various video cameras. Bottleneck trajectory investigations. This is another good candidate, especially in some areas where there's not a good place to hang cameras, or it might just be too dangerous to have a tech go in there. With a drone, you can just send it in the air pretty much anywhere, and you have the full view of everything you need. No need for multiple camera angles. It's the same with mainline congestion studies. As you can see, it's just a nice, full, clear view. Complex interchange TMCs, origin destination. I have plenty of personal experience setting up these types of projects with regular cameras, and something like this would be anywhere from 4 to 8 different locations. With one single drone, as you can see, you get the entire picture. You can see where everyone's going. You can see where they're coming from. It's just all the data is right there in front of you, and very, very clear and easy to decipher. Complex intersection TMCs, same thing, just one camera, one location. And say for one like this, we would need to set up locations here, 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 and here, whereas with the drone, we've got it all, just one shot. Finally, parking studies. Cool thing about these is how quickly you can get the results back. If you have 20 acres parking lot, you can generally survey that in about 20 minutes. You get a real-time feed as you're flying. It creates a map for you. There's automated counting software, so as soon as you're done flying the mission, the drone comes back, you already have a really good idea of all the counts, or all the cars that are there and everything you need to count. And once that's done, you upload it to the website. Usually within an hour or two, you get your ortho back. And I mean, it's a very quick turnaround time. All right, we'll talk about a few of the advantages of using drones and data collection over traditional methods. Obviously, the first one is safety. No ladders. We don't have to put any techs on ladders to hang any cameras. Generally, you would want to hang a camera about 18 feet in the air so you could ensure that you wouldn't have any vehicles obscuring it when they're driving in front. But in this case, you don't have to put them up on any ladders. Less time in the field, that's always safer, of course, and less time driving. Field techs don't have to go and pull over to the side of the road and hang the cameras in areas that might be a little precarious for them. Quality, of course, zero obstructions. I can't stress that enough. You don't have to worry about recounts or errors in the data because everything is going to be right there for you. Unique angles, you can pretty much put it wherever you want. The pilot in command is always on site. I view this as a benefit primarily because if there is a problem, you have somebody right there that can put another bird in the air if they need to. Troubleshoot whatever the problem is, and that would definitely cut down on the possibility of having to go out there and recount again. Maximum accuracy with 4K footage. It also allows for automated counting, and this software is getting better and better as time goes by. It's becoming more and more accurate, and is definitely something that is revolutionizing that part of the industry. And then real-time uploads, specifically with tethered drones. If you have like a 24-hour count, generally speaking, we would record everything and bring it back once it's done and then process it. But with a tethered drone, you keep it in the air for 24 hours. You can send a live feed directly to the VRC, or you can just download packets like 2 hours at a time and upload that so people can begin to process it immediately instead of having to wait for the count to end. Finally, efficiency. I've said it many times, but once again, one drone versus many cameras. And with the quality, just less time processing. It's easier for them to count. It's easier for us to process. And I'll touch on some applications, not just traffic related, but some other applications. And this list is by no means complete. These are just some of the main areas that you can use some of these different payload types with. With a 4K camera, digital optical zoom, you can get into different types of inspections: utility, transportation infrastructure, railroad tracks, overpasses, dams, wind turbines. Studies and surveys, mainline congestion, data collection, conflict analysis, intersection interchange, TMCs, PCI reports, and mapping, topographical mapping, 3D modeling, landscape and vegetation health monitoring. Just a lot of stuff you can do. If you switch that out to a thermal camera, specifically radiometric, We start getting into some utility inspections, power lines, chimney vent stacks, waterworks, solar farms, telecom masts, and some structural inspections as well, buildings, roofs, solar installations. And if you switch that out for LiDAR, you can do utility infrastructure planning and monitoring, power lines, solar farms, corridor mapping. Really, the sky's the limit with this sort of thing. It's a technology that is changing and advancing constantly. I'm forever, almost every week, reading about a new area that they've been able to apply drone technology to, or a new market they're going to be able to exploit. So it's constantly changing and evolving, but it's definitely growing. And that about wraps it up for me. If you guys have any questions, please feel free.
Hey, Tim. Yep, we have a couple that came in. First off, in reference to obtaining your license, what does the training look like? Like how many hours do you have to put in? What's kind of the steps you need to do in order to be trained to fly one?
Yeah, it's a good question. And it really just kind of depends on how well you can make or retain the material. There's a lot of stuff out online that's free that you can watch YouTube videos that they'll take you through all of the information that you need. There are also some great courses out there, but it's really not as difficult, I think, as many people like to think it might be. I mean, there is some technical stuff, but a lot of it is common sense and just learning to understand how to fly, what the rules are, what your restrictions are, what different types of airspace there is. So I mean, I couldn't give you an exact number of how many hours you would need to study. It's kind of go at your own pace, but it's definitely attainable. And once you feel that you've learned the material, you would apply through the FAA website. There are training centers all over the United States, usually in technical colleges, and you can just apply. Usually it's you have to wait 2 weeks and you go and you take your test. And then it's a matter of just waiting for the results to come back. So.
Cool. Okay, and then I think you kind of addressed this a little bit later on, but we had two different questions that kind of tie into each other. So how long can a tethered drone remain in the air? And for you, or for quality counts, what's the longest time that we've consistently had an airborne tethered UAV? And then are there limitations based on the hardware overheating or data corruption issues with extended missions?
No, it's a good question. And so.
Oh, are you there, Tim? You kind of cut out on us.
Hello?
Yep, you're back now. Yep, we can hear you now.
Okay, excellent. It's an interesting question, but you can actually keep these things in the air as long as you can feed power to them. Specifically, the way that they are designed, you don't really need to worry about overheating. Now that is, of course, dependent on the environment you are going to be flying the drone in. Obviously, if you're in 105-degree weather, you might have some issues. But in most of the applications, you can keep it in the air as long as you want. I believe for quality counts, we've kept one in the air at least for 24 hours. I think there was a 24-hour count we did. And Roxy, was there another part to that question? I'm so sorry.
Yeah, just with, are there, I guess you kind of answered it, limitations based on the hardware overheating or data corruption issues?
Gotcha. No, as far as I've been able to tell, no problems with that. As far as the overheating, no real issues with the data corruption. With the tethered drones, you usually have the ground unit itself, since it's hardwired into the drone, has the data storage. So it's not even being stored within the drone; it's being stored within the ground unit itself, which you have immediate access to while you're flying.
Okay, gotcha. Which kind of ties into a different question. Can you use AI to count traffic while the drone is flying in real time? What are the requirements to count traffic?
Yes, I believe that is that's something that I've actually recently been looking into. But yes, there is software out there that can work in conjunction with the drones and with the software that you're using, depending on what type of drone you're using, that can implement automated counts in real time.
Okay, gotcha. And then another question, if you're not supposed to fly over people, how difficult is it to fly over to observe schools?
Well, and that's another good question. That's one of the waivers that you can actually get from the FAA. If you're flying in restricted airspace, it's usually an instantaneous yes or no. But with things like this, you would have to submit a waiver 90 days before the mission, and then you would get permission to do so. So, but in a situation with a school, the school counts, they were stationary. They were sitting in the air in one spot the entire time, and that spot was roped off. I mean, nobody can walk directly under the drone. That's the interesting thing, specifically with tethered drones. There, you put them in the air, they stay right there.
Okay. And then what's the battery life for them? Will it capture a full traffic peak hour?
Once again, it depends on the hardware. With a tethered drone, absolutely. With a drone, with battery drones, most of them, I think you get about 45 minutes. And generally what we do is we have 2 pilots on site. So we have 1 drone in the air. And as we get to a point where it's got 10 minutes left, we'll send the other drone in the air, position it approximately where that one is, and bring the other one down. So you usually have 2 video files.
Okay, right. And for weather limitations, does rain mean you can't fly that day? I mean, what kind of are the weather limitations there?
It, again, depends on the drone. There are waterproof drones out there that are pretty affordable, so you actually can fly in a full downpour. Really, you need to worry mainly about wind conditions. If the wind is blowing over 25, 35 miles per hour, you're going to have a problem.
Okay. And then can data be collected for 7 days straight on roadways? Also, is there a camera that can handle both day and night without having to be swapped out?
Wow, that's a good one. For a question or for a survey like that, typically you would probably want to use something like DJI Matrice, where you can set up multiple cameras on the actual unit itself. And if you've got it tethered, yeah, you could absolutely keep it in the air for 7 days. So, yeah.
Okay. What is the max altitude with a tether?
I think right now I haven't seen any tethers that are over 300 feet. I think that's the max altitude they've got right now.
Okay. And then how many people are needed for a drone mission? Kind of.
It depends on the mission. Generally, just 1 person, the pilot in command. If you're going to have a drone in the air for a 24-hour period, you would want to rotate the person who is keeping an eye on the drone. But yeah, just 1 person.
Okay, great. Hold on, let me check. We have a couple of pricing questions, and I know we can shoot those over to Mark, but let me make sure we got all these other ones. Are drone counts available in every state?
Yeah, I mean, if it's in the flat 50, I think we do it. So, I mean, we're all over. So,
Yep. And have you had any experience with using an infrared, I think they meant to say infrared sensor, to detect vehicles in night operations without roadside lighting?
I have personally not had any experience with that, but I do know exactly what you're talking about, and it is possible, just depending on the type of infrared camera you have.
Okay. Let's see here. And then for the AI counting that you mentioned earlier, what software, do you remember what software it was that you were looking at?
I know that Drone Deploy is a company that I've done some orthomosaics parking studies from them, and I know that they have automated counting software built into their subscription service. Off the top of my head, I feel kind of dumb, but I don't remember some of the other names.
Okay.
Some of the other software.
No problem. Let's see here. Looks like we have another question. Can the data processing software identify types or classifications of vehicles, first by size or second by axle configuration?
Yeah, some of the software can absolutely do that.
Okay. And then, hold on, they're coming in, so I'm just trying to read them off. Okay.
No worries.
How do you map parking counts under tree canopies and any other related obstructions?
So in other words, if you have a parking lot that's got a lot of trees, a lot of coverage,
Right.
in a situation like that, we might not be able to use a drone. We might just have to go in with some of our other capabilities.
Okay. And then Mark, we have a couple of questions about pricing. Let's see here. What is the general cost range for, say, a full day parking study for a site like you showed?
Our rates generally start at $150 per hour of collection. But that's going to depend on the technology we use, obviously the location of the survey. There might be some travel expenses to incur. And then it's also if you need data reduced from that. So that's just for flight hours. But if there's additional planning involved, then we bill like a pre-flight planning fee to get through all of the coordination that we need to get through. And that's, contacting local police departments, any public agency we need to coordinate with, property owners, that sort of thing, which does take several hours to complete. And then data processing that can incur fees too. So if you need us to actually reduce the data out of the video or the imagery, then it has its own fees associated with it. But the price for data reduction is going to depend on the complexity of the classifications you need, size of the area, and an estimate of how many people we need to actually reduce that data. So I can't really give a precise answer for data reduction.
Okay, and then what about, is there kind of a general hourly rate for the hours of study and data collected?
I can say give or take $150 an hour, not including data reduction.
Okay, perfect. And then I think that's all for the pricing. And let's see here. What model of LiDAR usage suggest for, okay, let's see here. Yeah, I think that looks like all the questions. There was a question about the recording, and we will have the recording posted on our website, hopefully later this week, that you can share with colleagues or friends or whoever else may be interested in the information. And if you answered a question and we missed it, feel free to email us at info@qualitycounts.net. But Tim, Mark, thank you guys so much for your time. Very informative. Again, if you have any follow-up questions, feel free to shoot us an email. Tim and Mark, I'm sure, would be happy to answer any questions that you have. So thank you, everyone, for attending, and I hope everyone has a great rest of their week.